Hello, dear students. Uh, in continuation of topic superconductivity, in last week, actually we saw all the concept which comes or which are in the topic of superconductivity. We had already discussed in last video lectures. Still, we want to revise that whole chapter in today's video lecture because this chapter is having 5 marks in examinations, and also this topic is very important in today's day because we use this different materials of superconductors for different devices or for fabrication of different devices, electronic devices. So let me start. As I said earlier, Lord Kelvin in 1848 suggested that the lowest limit of temperature is absolute zero. To keep this thing in mind, a Dutch scientist, Kamerlingh in 1853 to 1920 pursued throughout his life for obtaining a low temperature at low temperature where liquefaction of helium takes place, which is just 2 Kelvin at atmospheric pressure. And because of this discovery, he got a Nobel Prize in 1930 for his investigation of the properties of matter of low temperature. He produced a liquid helium, and this research got a huge important in the nowadays. He chose mercury metal for his study since he can purify it by distillation. So let me define what is superconductivity. According to Kelvin, low temperature research has led to the discovery of amazing phenomena of superconductivity. For a long time it had been known that conductivity experiment, the electrical resistance of metal decreases with decreasing temperature. He found that the resistance of mercury decreases with decreasing temperature and it falls extremely low value, that is almost zero, that is near to 0 Kelvin value. For helium it is 4.15 Kelvin. At this temperature the impart is very high electrical conductance. Then it has been found that the number of metals and alloys, the electrical resistance disappear abruptly or completely at temperature. The phenomena of abrupt disappearance of electrical resistance at very low temperature, which impart high electrical conductivity to the conductor and making it superconductor, that phenomena is called as superconductivity. Here I request all the students of TYBSc to keep this definition in your mind. Remember always, because the definition is having its own importance. That means when there is abrupt disappearance of electrical resistance at very low temperature which impart the very high electrical conductivity, that means those material which having very less resistance, that means they having very high conducting behavior. And if it found at very low temperature, then that materials are called as a superconductor, and the phenomena is called as superconductivity. Everybody understood that? Now let me see transition temperature or critical temperature. Nowadays, materials are said to be superconducting when they having no resistance or zero resistance to the passage of electricity. The temperature at which superconductivity occur is known as superconducting transition temperature or critical temperature. That means at any temperature where superconductivity occurred, or the phenomena where there is abrupt disappearance of electrical resistance with high electrical conductance, that temperature is called as critical temperature, which is denoted as Tc, and the material is called as superconducting material. At ordinary temperature, when metal has a measurable resistivity, okay, that means at room temperature when metal has a measurable resistivity, but when you decrease the temperature, resistivity decreases and conductivity increases. That you have to remember. At very low temperature of 3 to 4 Kelvin, resistivity abrupt suddenly and making the material as a conductor, called as superconductor. So that temperature is called as critical temperature. Everybody understood that? Now, this can be seen with the help of this diagram. A superconductor has practically zero resistance, electrical resistance. Since it can be carry an electrical current for ever without dissipation of energy, due to which the current induced in the superconductor persists to the years to that material with. Now next phenomena we saw that is also very important, called as a Meissner's effect. What is Meissner's effect? Let me see. When a magnetic field is applied to the substance, the flux lines of the field pass through the substance. That means when you put a magnetic field near the substance, whatever the magnetic flux lines comes from the magnet, that will pass through that substance. The extent to which the line passed through it is called as magnetic permeability. But it depends upon the nature of substance. According to Meissner's, when the magnetic field is weak, the superconductor expels the magnetic flux line where magnetic permeability is almost zero. This effect of ejecting out the flux line, that means when there is a effect of ejecting out the magnetic flux line, then that effect is called as Meissner's effect. So that can be seen with the help of diagram. In first diagram, when at temperature is greater than critical temperature, when the magnetic flux line is passes through that substance. But in second case, when the critical temperature is greater than temperature, at that time what happened? The substance expel the magnetic field. It will not allow to go into it, right? So that description you have to keep in mind about the Meissner's effect. According to magnetic behavior, the superconductors are classified as ideal superconductor and hard superconductor. Now, how we can define ideal superconductor? Ideal superconductor is a superconductor where magnetic flux lines are repelled totally after critical magnetic field Hc. The magnetization drops to zero. That is called as ideal superconductor. And for hard superconductors, the magnetization doesn't comes to zero. Everybody understood? When magnetization drops to zero, then ideal superconductor. If it is not dropped to zero, then it is a hard superconductor. Okay, so that concept comes from the Meissner's effect, that you have to remember. Now let me see types of superconductor. There are three types of superconductor: conventional superconductor, Fullerene alkali metal superconductors, and high temperature superconductor. Now what is conventional superconductor? A conventional superconductor is a superconductor which required liquid helium for cooling. That conductors are called as conventional superconductors. So we have examples of niobium and its compounds or its alloy. Niobium displays highest critical temperature of 9.4 Kelvin Large number of compounds of niobium shows different critical temperatures, and at this critical temperature they shows as a superconducting behavior. But niobium alloys are brittle and cannot be fabricated in the form of wires. So far, vanadium, gallium, and niobium aluminum have been manufactured in sufficient quantities and used in different coils. So that you have to keep in mind. Fullerenes and alkali metal fluorides. As you know that it is the second type of superconducting materials. As we know that fullerene is one of the allotropes of carbon called as Buckminster fullerene. It is a geodesic dome, or it's a very giant molecule, like unlike diamond and graphite. Fullerene having definite formula of C60. Nowadays we have C70, C80, C90 also. Its shape looks like a saucer ball or a buckyball. It having 26 member ring and 12 5-member rings. So fullerenes have been discovered so far in universe. So look at the structure of fullerenes. It is a saucer ball like or buckyball. It having a hollow room inside the ball where the metal ion can trapped. The outer surface of that fullerene shows a chemical reactions like benzene, and that's why it also having the phenomenon of superconductivity. Okay. In fullerene C60 there is a sp2 hybridized carbon is there, and because of that 5-member rings are introduced. The structure curves in one hand. After the discovery of fullerenes, a number of compounds of fullerene or fluorides are reported. When fullerene reacts with metal, they form alkali metal fluorides, and at very low temperature they can behave as a superconductors. That is about the Now third type of superconductor is high temperature superconductor. Again, it has two types. One is called as superconductor whose critical temperature is below 77 Kelvin, called as low temperature superconductor, and second superconductor whose critical is above 77 is called as high temperature superconductors. So we have many examples like some inner transition element like lanthanum, barium, copper, oxygen when combines at 34 Kelvin, which was a Nobel Prize winning discovery. Also, that is one of the superconducting materials. We have plenty of examples here. Okay. Now, application of superconductors. It having very used application in day-to-day life, as I said earlier also. In linear accelerator, they are used as an atom smasher. High energy profile used in physics research. They are used in nuclear fusion research to make powerful magnetic field which act as a magnetic bottle for plasma. Now, they are also used in NMR machine. They are also used in a superconducting quantum interference device to low noise amplifier. So there are plenty of examples or application. It is used in computer also to generate powerful electromagnets. Even in Japan, a prototype of a train which floats on magnet field has been built using superconducting phenomena. So these are the applications you have to remember. Again I will say here is that on this particular topic 100% 5-mark question will be asked on superconductivity topic. Okay, so here we finish this topic. In next video lectures we will start molecular orbital theory.